G'day guys, the saga continues and I'm going to give you some very important advice. I need to find the bottom of this right here. There we go. To get this apart, you can run a sharp blade this way around and on the outside and it will come apart. But what I discovered, the filler they've put in the groove was binding to my cutting blade. It was really difficult to do. So a very fine, I don't know if you can get a vertical coping saw or something like that, but zip around. So idiot me did it a different way. I was going to turn that down a little bit like that. Okay. What I did, because it's got a filler around, I did it with the soldering iron. And if you can see there that it's, I've just basically put a conical bit on the soldering iron, gone round, and that's the plastic which has just jumped up. So you could rebuild the coil easy. All you do is just cut that off with a knife or whatever and put it back together and rub more filler in there. Because what I was trying to do is get this apart and preserve the coil, right? And yeah, this resin in here and also the boot here, you have to cut this thing off the boot without wrecking the wire, but it's got a little infill in here as well. So, and it's bumastic. It's horrible. It's very, very difficult to get off. This has had some sort of bumastic glue and then it's had a heat treatment on it and it's really difficult to get off. So my advice would be, if you're going to do this, don't try and preserve the coil, just bust it into a million pieces and do it. But I was just trying to do this, trying to be extra careful. But yeah, and when you pull it off, the earth wire falls off that as well. So it's easy enough just to very fine tack another little wire onto that. You can put it back together. But okay, and I'll tell you what happened. This is a warning to everybody who gets into a coil like this, and I'm pretty sure that this is a type of ABS. Have you ever heard of the word ABS poisoning? Right? I didn't think it was real because I remember when I got a vacuum former too. When we were vacuum forming ABS coil shells some years ago, I always felt really, really horrible after doing it. And this is probably, I'm going to tell this to anybody working with ABS who is in an enclosed area working with it, because I did a bit of research and I found it's actually a thing. People with 3D printers doing ABS in a closed room will get ABS poisoning to some degree. There's no instant cure for it. It's basically lots of fresh air, drink lots of water, take a lot of vitamin C, take selenium, take NAC. I've just pumped myself full of vitamin C, about, I don't know, about, I don't know, 10 or 15 grams of vitamin C, heaps of NAC, which is detox, and selenium, which is also a good thing. There's other stuff you can take, but not going to get right into it. Last night, after doing this, late at night, I felt a little bit off colour. And because I'm in the workroom, there's no ventilation. So there's me going around with the soldering iron. So you think of the circumference of those two circles there, that's how much I did with the soldering iron. I didn't have it so it's smoke going everywhere. I just had it so I could just melt the plastic, but it fumed enough. And I got the worst sore throat and stinging sinuses ever. And it woke me up multiple times during the night. Felt really, really off colour. So this isn't right. something's not right. And anyway, in the morning, I still had this burning feeling in my throat. Eyes are a bit stingy, sinuses are stingy, and bloody, what caused this? I thought I might have had another dose of COVID or something, you know, the flu, whatever you want to call it. But anyway, I typed in ABS poisoning, right? It's actually a thing. It's yeah, it's a thing. So be careful with ABS in a enclosed area, or else you're going to cop what I copped. And I've still got it, a little bit in the throat and sinuses. So you got to drink tons of water. You should have all sorts of stuff that give you a good detox. But it's just lots of, I'm in the room again for door locked, but lots of fresh air. And it just basically is it goes away eventually, I hope. God, I won't be doing that again. Because I've worked on ABS before, and sometimes I've actually, instead of using, you know, some sort of solvent like acetone to stick it, I have actually used a little filler rod of ABS and just heated it up with the hot air gun and laid it in there. And when I think about it, I haven't felt well after doing that as well. And you just don't think about it. Not the ABS. It's got a lot of the ABS has UV stabilizers put into the plastic, and it's those are volatile and they come off, and also I think possibly the ABS as well if you heat it. But anyway, back onto the coil. Um, it it didn't kill me, so whatever doesn't kill you makes you stronger. Is that what they say? I don't believe that, but anyway, we have a look at this thing. As you can see, um, yeah, Chet's put some comments in the comment section of the first video I did on this, and he's he's already measured everything out, so it saves me having to do it. These coils have a very, very thick, low resistance winding, and if you read the comments, he's gone and pulled it apart and counted it all. But I want to ask this, because this is so low in resistance. People sent me pictures. People have done this. They've pulled these apart and probably trying to do exactly what I'm doing. But I'm just going to quickly measure the resistance on this. I'm not going to do it with my accurate fluke meter. I'll do it with this. I don't even know what this thing is. Unbranded. Come from JCar, I think, somewhere like that. Anyway, let's have a look. The resistance on this coil. Now I'll put this down. So I usually do it over an inch or a centimetre, whatever the case may be. All the wires are twisted. So if we basically go on here and do something like an inch, or 25.4 millimeters, whatever it is. Okay, 49 ohms. Now, is that accurate? Probably. Oh, there we go. If you get a good bite on it, gets down to 30 ohms resistance. I don't know if you can see the meter upside down. How about I turn the meter around like that? And try not to tangle myself up. There we go. Use it as a stand. You can probably see that now. But if I go on here and get some good bite into it, oh my God, look at that. If it stays there, it gets really, really low. 23. Yeah, 20 ohms. And go across the whole thing as far as I can. Well, I'm not really getting a good contact on this because it's got a lip on it. But yeah, 152, but I bet you it's lower than if I got a really good bite on it. What if I can do it that way? I'm trying to get the leads down hard on it, but it's very difficult because it's got little raised edges. Okay, 148 across the whole thing. That's extremely low. Having that as a circular Faraday shield on the coil, that will act as a resistive load to some of the energy from the coil. The coil's a transformer. You put another winding, around that way here, and the energy will couple into that winding. You can look at that as a single turn, and it's resistive. So some of the energy is going to get dissipated in that. It's not going to feel hot or anything, but it will, and it's probably more of an effect on the receive than anything else. But it is small, but it does exist. So there must be a reason why they went so low. And it's not just here, it's inside the shell, the back of the winding, and back around again. So the whole thing together got a nice resistive cage around it. So if I have a look, I have to pull the winding out to actually have a look at how they've done it, if they separated this from the other part, or if it's joined up, or they just use a couple of very fine wires to join it like they do in the other coils. Don't know. But yeah, that's what it is. Now, in this cage, we call it a little plastic cage, we all know that if you bang a coil, some coils, I'll put this back up again. There we go. On some coils, you bang them on an object and they sound off because it changes the interwinding capacitance and just placement of the wires to the other wires. So these very, very thick wires, I'll just point this out. I don't know if this is a real life issue or not with this particular coil. But if you can get in here, all these windings, well, the wires themselves. I'll just focus on this one because I can get to it. It starts sticking up a bit. You can move them really easy. They do. That one there moves quite a bit actually. But hang on, I'll try and hold this so you can actually see it. Okay. Yeah, that one there. You can see that up and down. Movie. So when you bang these, I don't know. I haven't done it. My opinion. It's not my opinion. It's actually fact. If the windings do move against the other windings, it will make a change in the coil, and it can introduce noise. So I don't know. Look, it's I don't know if you can even see that. Where my finger is, look, watch this. The whole bunch moves. It's very, 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 very spongy. So I don't know. It's got me perplexed. So yeah, I'm not saying it's a good thing or a bad thing. You make up your own mind. But I will say this: they haven't soaked the whole thing in resin, which kills the Q of the coil, and does affect the efficiency of coils by doing that, especially at high frequencies. So that is a plus. It is got a fairly decent. It looks like it's wound in polyamide, and it's got I think quite a few layers of it on the actual lit bundles. I'm just being what's obviously it's observing and seeing what's obvious. That's why I should say it. It has these little blue things put in here. Okay, these little blue spaces. They are meant to, if you can see where they go in, they're put in. They actually pop them out, but they're put in to hold the winding in place. Now, God, that's spongy. What I would do, my opinion, no one else's. Every one of these gaps, I would fill each one of them with a blue spacer. That means that it would keep the coil windings in compression and stop a lot of possible movement by having the coil go over hard ground, rocks, bump into things, whatever. I could actually get this, go out in the field. I am going to Faraday shield on this side of it, but use something insulated like a plastic rod and poke these wires, so I'm not doing any capacitance effect on the coil to make it like real life, and see if it goes woo, woo, woo when you poke the windings. I don't know. I haven't done it. So I can't do this. You can't do it in the workshop. The bloody detector sounds like a banshee. There's no way known. Anyway, one of the viewers, yeah, said basically, here's a coil, go for it. Now, I had someone else go around David's place and um, tried to give him money for this project, but David said, oh, we've already got a coil, so keep your money. So I'm not going to be you know take advantage of the situation. So don't send any money. Someone already has on PayPal. I feel like you know if you want your money back, I'll send it back to you. Just let me know. Just send me an email, or I will put it towards an ongoing project, even just putting it towards a double D coil or something of that nature, because the little dongle is sitting in there in all this resin. Now, what I've also noticed as well, this resin, if you heat it with a soldering iron, tip falls apart. It's actually it's quite stiff. And what I've done, I've worked out. I don't know if you can see in there. I've worked out exactly where the wires run and where they don't, and I actually drilled beside where the wires come in. You can see there, I've drilled it because it's very thick, and in the bottom part of the coil, it's stuck like the babies, what, to a blanket. It is absolutely, on there. It won't come off. So I've got it free from the sides, but like I say, I was trying to get the whole thing off and deal with it as an entity rather than just, smash, break, cut, destroy, uh, just for the sake of it. I don't know if that's a good way of going, but it is what it is. And I'll tell you something interesting too, of the design of this coil, how it's all hollow in the middle here. Yeah, I could pull some stuff out of my drawer, which I've done years ago. It's the same. So yeah, it was a way of getting weight out of the coils, and basically you don't need a massive, big, flat Faraday shield over the whole thing. But don't worry about it. I'll leave it there. It's got some other design criteria which David actually did, so I'm not going to show off his design work. But yeah, um, yeah, Faraday shield on that side as well. Yeah, comes up there, goes there. I think that it's actually separate here to the side, and because the way it goes in, it goes down a couple of millimeters, and they just do a small wire join from um, basically the ground of the coil on the what is basically the outer shield of the lit wire uh, to the top, and then sandwich it together. However they build it, maybe they run the wire up and then they stick that there and they pour this in later. I don't know. I've never seen them put one together, but um, they've done some good ergonomic design work. You can see that they've actually not let this be a flexy piece of um, material. They've put in some, strengthening, so take out some of the movement uh, that way, and yeah, you're not going to get any movement that way. So yeah, structurally it's good. It's a good design. The only thing that I'm interested in is the possibility of the windings to move. Even if I hold that cage like that, no, I can still move the windings. And that's funny because it was always an issue on the older detectors, um, on early beep coils, not saying the name, but yeah, that there was a lot of slop um, where they had put the cable in and connected the coil to, and because it moved around, it was all soldered connections. It would sound off really badly. I didn't say any names, okay? Didn't say any names. So you can guess. Might even be an overseas company, I don't know. Well, I do know, we're not saying. But yeah, that's that. So that little dongle, the dongle sits in there. There are meant to be quite a few issues trying to make a standard coil work on these. But here's the kicker, right? If it does, you can modify the detector with the current sense resistor if it does cause an issue. Like it says, oh, that coil's not pulling enough current. Well, there's no coil there. Basically, because the way this is wound, I think Chet said that the winding is equivalent to 12 AWG in resistance. So that's your yardstick. And you can, I would do my Litz bundling differently. This is just my opinion, how I would do it. They've used, I think what was it, 0.22 or something, 0.21, 22 mil stranded Litz. I'd use 0.12 and a lot more wires. There's reasons for why I would do that. They have, by look of it, with the winding, well, the Litz windings, the insulation polyamide. I can't remember the dielectric constant off the top of my head. I'll have to go look it up. But I think they've actually got the spacing between the actual wires pretty close to perfect. I would estimate there is, well, if you treat the that insulation on the windings, treat it like air, even though it's not air. You know, air's the best thing, but how can you mount air to air? You can't. You've got to somehow have the windings next to each other and keep them stable, or attempt to keep them stable, whatever. And I would say, yeah, well, it's a far cry from filling it up with resin and doing it that way. And I actually, I like the idea. I like the idea. And yeah, my door is opening. It's now closing. Yeah. So with this, I would don't do what I did and use a soldering iron to melt all that and pull it apart. Ah, gotcha. It's all right. I left it there for you. So, what do you want now? You want the little whizzy thing? Here. And you might need that. And you might need to change the collets, which are here. Yeah, collets for that. Okay. All good? We've got big smiles. It must be all good. Yeah. So, yeah, the only thing, in my opinion, I don't want it to rain fire and brimstone on me. In my opinion, which is completely probably wrong. It could be, couldn't it? Just an opinion, a personal opinion that I would run. In my opinion, would put a lot more of these blue things holding the wire bundle. Guys out there, if you got one of these and you're in a quiet area, bang the coil and tell me if the coil sounds off, please. I want to know. I would have to actually go out and do that. But so if you got one of these, bang it. Or if you have other ones, other manufacturers' coils, whack on the side of a tree. Tell me if the coil sounds off. I want to know. Because I don't know, because I haven't done it. If I haven't done it, I don't know. It's obvious, isn't it? But okay, that's what we got. You also notice I'm gonna point out a few things about the coil design because I've made a few coils in my life. The way that sits in there, that sits there, goes there. they've actually left quite a lot of spacing between the shielding, as in the black stuff, and the coil winding, which is good. Now, it's good because it reduces the capacitive effect on the windings from the shield. And as it's a very low impedance or low resistance shield, it can impact on the Q of the coil. So let's have a look and say it is actually good spacing. It goes there to there. It's I'd say it's a good 3 millimeters. Now, some people would argue, oh no, you want to have the windings really close to the ground so you get the smaller targets. Yeah, but there are trade-offs in every coil design. If you have it very, very close, you're going to capacitively load the coil windings to the shield. It will impact performance in that way. You may get a bit better signal if you go over a target near the windings, very, very small targets, like I'm talking in fractions of a gram type stuff. But maybe in my opinion, they have probably done the better design, the better way of doing it. Like I say, you ask 2 designers to design a coil, it will not be the same. I'd say even if you ask 10 designers to design a coil, they'll all be different. No one has a consensus on, do this way. Some will say we want to have the coil performance, optimum and get rid of any sort of losses and less reaction to the ground through the shielding. And others will say, no, get the windings really close, right? Or stagger the windings. Or, let's run the windings, out here and we make a coil does everything and suffer the consequences. We'll lose depth, but we'll gain, small target inner sensitivity. There's all trade-offs. The whole design of these coils is trade-offs, but yeah, that's that. So, guys, the guys who are out there and done this, I think Chet and Benny were the ones helping me out with a bit of information on they've pulled these apart and tried some things. Some other guys too. I actually went and had a look around, and there's a few people that have done some interesting things with these, but there seems to be a bit of a issue trying to run a normal coil. I will look into that. You could do a modification within the detector. I know people don't want to do that, but you could. You could probably look. You could probably do a lot of things if you want. You could probably lower the value of that resistor, beef up the output stage, put higher, or should I say higher performance? How about lower on resistance drivers and all sorts of stuff? There's a lot of things you can do, but it's going overboard. And what I'm thinking, for the way to do it, if we get the dongle thing working, okay, and we can just hook up normal type coils, you can buy coil shells, get them out of where, a place that has a red flag with, what I mean, and build your own coils. Just make them out of thicker lits. As long as you work out the stranding, work out ohms per meter or foot or whatever for 12 AWG, and just make your lits wire the same. So you got the same ohmic resistance over the same distance. And it doesn't have to be exact anyway. It depends on how much current can be sourced from the detector during a pulse. And if you go too low in resistance, it's not going to do anything. It's going to burn up in the resistor inside the detector. Not burn up, but I mean, it's going to get dissipated as heat. A little bit of heat anyway, enough to sort of touch it and go, oh, that's getting warm. But yeah, overall, it's good. The only thing I don't like, and like I say, just my opinion, is that the wires can move. Like I say, I don't know if they do. I haven't banged it. If you want, I could actually hook this up and No, I actually could. I could do that. I could hook it up on the oscilloscope, right? And we could um, bang it and see what happens. You have to look at very low levels. I probably have to use a preamplifier on the oscilloscope to see it. But these detectors, these things look at nanovolts, and that thing there goes down to 2 microvolts. So I want to run my I got a wideband amplifier I made up for it, so I could probably hook it up and bang it and watch it go whoop 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 and generate spikes. But maybe it doesn't do that. Like I say, just my opinion, and this is just educational. Okay, so everything's educational in how to make a coil, how to design a coil, and how coils are designed. So, if anyone's got any idea about removing this resin here without affecting the plastic, please let me know, because I don't know of any way I can do it without getting in there and, you know, making some landfill out of this coil shell, because that's all it'll turn into. If I can get it out in one piece, or someone, if you can, send me the picture of this part here. Look, because this is bumastic, I poke in there and it's all rubbery, but has it got a secondary lip in there under it or not? I don't know. You know, I don't want to keep digging around in here. It's because I can't cut it in here. It's very difficult. So the only way, you know, you do it, you just go cut through there and cut through there and just pull the plastic away, and then it comes out, of course. But I'm trying to avoid doing that. I'm trying to recover the structure of the coil shells, basically, so we could use them to try out, maybe use these to put other windings in there. You know, I could put one of my um, double shielded low resistance shielded windings in there. I don't want to say too much about that, but yeah, it basically cuts out a lot of, saying too much, but I will say it, damn it, cuts out a lot of RF interference, okay? So the coil remains beautiful, as in picking up targets and everything, but it cuts out a lot of EMI, okay? Just by different technique, which I'm not going to go into, especially here, because yeah, it's these days it's well, they changed it. They changed all the patent rules. It's called first to file, which means you can come across something and no one's patented, you can go and patent it. As far as I know, that's my belief on the subject. So you've got to be careful what you open your mouth about, because if you think it's commercially valuable and you go and blurb it out everywhere, well, it's open slather. It's no protection anymore, unless someone does and tries to run a patent on it. You know, the other thing too, I was going to make mention of. Damn it! I need to drink water, so I made this massive coffee, and then it's going cold on me, so I'm going to have some anyway. Throat's a bit raspy. That is strong. Oh my god. Oh my god. That's yeah, Italian coffee, and I think it's Italian. It might be Brazil. I bought a whole heap of coffees the other day. No, it's actually Brazilian. Okay, it's very strong though. I was going to do a thing about showing. I'm going to do an educational video. I'm not going to do it now because it would go for too long. But what I'm going to do, these cores, these ferrite cores that are in most detectors, and also have I got one here? No. They're also inside the X coils, and I suspect also they'll be inside the MindLab coils for the 7000. I'm going to show you some very, look, what I've been saying for ages, and no one ever listens, of course. They don't take any advice. I'm going to show you why you don't use these. All right, don't use these, and I'm going to show you why. Or should I say what you should replace these with? See, this is really letting the cat out of the bag, but I don't think I'm going to be in a situation to make coils. These type of ferrites, these things that are everywhere, I can't remember the grade, but I did work all this out, and it's written in a book somewhere, but they're very, very high permeability ferrites. And you gotta be careful when you run ferrites, especially you can't stick ferrites normally like this. It's called an ungapped type core. You got the split cores, you know, the ones you clamp. Technically, you got a little gap in there. You can't run DC through these; they saturate, and they can basically do all sorts of funny things. Actually, they can cause harmonics, believe it or not, in radio applications. But what you need these for, you need to run a proper like AC line or something through these, where you have a reset mechanism where it goes positive, negative, or in square waves it goes up, down, up. If you just keep belting these with square waves, they can saturate really easy, and they can cause problems. So there's but they put these in the 7000 because it actually transmits this way than that way, right? So it's got a reset mechanism. These things don't saturate, and you get sort of all sorts of funny distortion effects. But anyway, there is another issue with these, and I'm not saying it's. I'm not going to say anything. I'm not going to say it's detrimental, right, to the performance of a coil having these in there. But there is other ways of doing it. I'm going to actually show you in another video. I'm going to set up a whole setup, and I'm going to use these. I've got a whole heap of different cores and core materials, and I'm going to explain why these should, in my opinion, not be inside metal detector coils. No, 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 should not. And we'll call it, I'll think of a technical term for it. We'll call it the ground balance offset issue, or possible issue, in my opinion. Okay, everything's in my opinion. You must understand why I say that, right? Because there's some in the past I have not said in my opinion, and it will rain down fire and brimstone on you. You must say it as a personal opinion, not as a fact. Even if it is a glaring fact, do not say it as a fact. Do not. Believe me, right? It's like if you do get caught up in libel or defamation. Don't say blah 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 is a prick, or words that are even worse than that, or whatever, right? In my opinion, I think so and so is a prick. Okay? That's how you do it. Use the word my opinion. It's recognized in most Western countries as a right of free speech, and it's protected by signatories to various conventions on human rights. Okay? The word, my opinion, you can say it anywhere you want. People cannot construe that to be a dedicated fact that you're applying to something or someone. So basically, if you have anyone who is litigious, as in wants to sue everybody around the place for any particular reason, as in some cases justifying their own existence or their own jobs, I'll put that out there as well, in my opinion. And yeah, always have it as your opinion. Okay, just an opinion. And if it's a fact, you want to very carefully record what you are pointing out to be the fact. Okay, even though I grabbed that coil and I said, oh, look, the wires move. But we know from past experience, in my opinion, that's not a good thing, right? It, it isn't. But that's just my opinion. I didn't say it's bad. Maybe it oscillates with the target in the ground and makes the coils wobble and give you a better signal. Sorry, I'm just taking the piss. But yeah, you just got to be careful what you say, because no company, and directors have an obligation to protect their companies, right? And if it's a company with less than 10 employees in Australia, you keep your mouth shut. If it's a company that has more, you can probably get away with a little bit more, because you can express factual information, and you are protected in Australia anyway. But if it's a smaller company, they can still try and have a go at you, and even though they can't win the case, they'll try and tie you up with bloody paying solicitors and lawyers and stuff. So the thing is, in that case, what you do, get all your facts right, document everything, right? Take it. If they take you to court, self-represent, go in there and just produce everything to the judge, right? Prove it. And then you've got no bloody leg to stand on. That's how you do it. You got to prove it, right? So document video. Have even second opinions. You can get second opinions from experts in particular fields. Anyway, I'm going right off course here about these coils and ABS poisoning, right? Should coils have a warning? Do not heat. It lets off fumes and you will die. No, that's a joke. It's like inside metal detectors generating close to 200 volts. Should it have a warning on it saying that if you open this up, you're going to get zapped? There is a chance that you're going to die of a heart attack if you touch this. Should that be the law? I don't know. Some jurisdictions it actually is, but I won't go into that. You can work all that out for yourselves. I've been doing this long enough to know my way around certain aspects of the metal detecting industry as such. Anyway, that's enough of this video. I will show you in the next video, or hopefully something else doesn't crop up and I have to make another video, or I want to make another video. It's probably more the point. I will definitely show you about ferrites and other similar things to ferrites. They're not ferrites. There's iron powder and there is ferrite. Iron powder is not ferrite. Please understand that. Even though people call anything that looks like a cylinder or a ring a ferrite, it's not a ferrite, it's iron powder. And there's various types of iron powder that have additives put in there to change the structure, the crystalline structure of it and how it works. So, ferrites are rare earths. Iron is not. Okay, it's not rare. Go out to WA. Yeah, that's it. Okay, it's 44 minutes. So beware of ABS poisoning. Look it up. It's actually a thing, and you have to detox from it. So I'm feeling a lot better now. I've pumped myself full of all sorts of detox stuff, right? I feel freaking heaps better. But yeah, I woke up with it last night. I had a bloody whopper of a headache, and it's just everything was crazy. The sore throat's gone now, and the stinging in the sinuses is gone, and the eyes feel a lot better. I can actually, yeah, can really tell that it does wear off. But I really should be outside getting fresh air. But I've still got work to do. I've got to get people's detectors done. Yeah, so all good. That's it. I'll cut it off here. Catches.